What we've designed is the most complex system that we've ever done.
This is a deployable reflector array antenna prototype that we designed for the Air Force.
For 5 years, we've been working to design antennas that would deploy on spacecraft. This work was initiated because of a partnership based on origami-based design.
Origami-inspired designs can fold flat, and those designs can be very compact.
And so that was one of the real big draws of origami for space application, because you need something to be stowed really compactly. Ideally, it's also supposed to self-deploy, meaning that it will just pop into its flat state perfectly every time.
And when you open something up on the Earth, we often open it on a table, and gravity pulls it down nice and tight on the table, and we can go around and pat it into place. And this project has really challenged us on how to open those up and have them be stable when they're open.
So we designed some special hinges.
So you see it can wobble a lot in this direction, which is nice because that allows it to deploy. But I'm gonna pull down on here and it's really stiff and really resistant to breaking.
Those allow it a little bit of wiggle room so that everything can kind of expand as needed.
But if you have just compliant mechanisms holding everything together, you could imagine that creates kind of a floppy mess.
And so the really important thing that we did was use magnets
to make sure that it consistently returned to the same deployed position.
The Compliant Mechanisms Lab is well known for creating mechanisms that move because materials bend or twist or distort in some way.
I think it's pretty cool that we're using this ancient art form to inspire our engineering.
It's just so fun to be able to see something going from a paper to space.
We've been able to be inspired by the work of so many other people, and having people come together to do good in the world is just inspirational all by itself.